The Vision2Action Symposium series on sustainability in the built environment is an ongoing series of regional conferences that facilitate provocative, strategic conversations around bold, visionary initiatives gaining momentum in specific regions of the Pacific Northwest.
The following keynote presentation is from the Friday, June 7th Vision2Action Symposium at St. Martin's University in their new LEED Platinum Engineering Building. The topic was the Architecture 2030 Challenge, presented as an opportunity for the Sustainable Thurston regional planning process to reimagine its draft vision, goals, and strategies based on climate change and economic realities. We welcomed Vincent Martinez, Director of Research and Operations of Architecture 2030 Inc., and a board member of the Seattle 2030 District as our keynote speaker. Vincent Martinez.
So, just to jump in a little bit, if you're not familiar with Architecture 2030, we are a nonprofit, nonpartisan research organization based out of Santa Fe, New Mexico. We're essentially a think and do tank. And we got started by the architect Ed Mazria. He's a well-known author, educator. He's taught at the University of Oregon, University of New Mexico. He wrote a pivotal book back in 1979 called the Passive Solar Energy Book while he was at the University of Oregon. Really looked at climate load dominated buildings and looking at passive solar strategies, and was a tremendous resource. They call it the Bible of solar energy. And Ed had a very successful practice for 35, 40 years and did some really great work, won a number of design awards, but close to early 2000s, he started to research a little bit more about the building sector and climate change and sustainability, and came up with a whole new way of looking at energy statistics and really pointing the finger at a different culprit in terms of who is responsible for the energy crisis and energy consumption and greenhouse gas emissions. So what Ed really found out is that climate change, which we heard a little bit from Chris about, there's a lot of repercussions about climate change. Thank you. Chris talked about rising sea levels, ocean acidification, forest fires we're dealing with in New Mexico where our office is based. Record forest fires for the past couple of years. So what we've understood is that the climate change crisis is really an energy crisis because we burn fossil fuels in our energy systems that contribute to those greenhouse gases. And so the major fossil fuels that we look at are coal, natural gas, and oil. Now there's some other non-conventional fossil fuels that are happening now like oil shale and tar sands, which we'll talk a little bit about. But really this is the direct connection that we're going to make that comes back to how we can affect climate change. So climate change crisis is really an energy crisis. And if we look at those supply side of the energy systems, those coal, oil, and gas, what are we looking at? So if we look since the beginning of the Industrial Revolution to current, we just passed 400 parts per million CO2 in the atmosphere. I know that was in our handouts. That's pretty sad news to see because the scientific community, specifically James Hansen out of NASA, has said that 350 parts per million is really the safe number for us to have sustainability in terms of the future of our civilization. So we actually need to start pulling CO2 out of the atmosphere. But if we look at the fossil fuels that we burn to get to us to this point, the red bar is coal, the gray is oil, and the yellow is natural gas. That's how much we've burned so far in the world. And there's the irreversible climate change line, 450. So again, we're supposed to be at 350, but 450 is this. We shouldn't go any further than that, or else we start what they call positive feedbacks, which I really think are negative feedbacks. But they're where we start melting the permafrost and things go cycle through, and we can't really stop it. So we don't want to go beyond that line. Now let's take a look at what we have in terms of proven world reserves. This is how much gas they say we have left, and with fracking technology, we're probably going to start to use more and more of that. This is how much oil we have left. So what you'll see between these two is that if you look at the oil bars, they're about equal. What we have left and what we burned so far, which basically means that we're either at peak oil, we're close to peak oil, or we're past peak oil. What do we have a lot of? Well, we've got plenty of coal, and we've got plenty of tar sands and oil shale. These are the things we need to keep in the ground if we're going to stop climate change. Those are very easily pushed us past 450 parts per million into irreversible climate change. So when people say that there's no silver bullet to climate change, that it's only silver buckshot, we have to do everything. Well, I think they're not really looking at this picture. Here's our silver bullet. No more coal or oil sands without carbon capture and sequestration. Then we have a chance of stopping climate change because we won't burn up the rest of those fuels. So how do we do that? Well, we talked about this, that's the supply side, but there's two sides to every coin, and the energy coin has a demand side. And when we think about demand, typically we have thought about transportation, SUVs, we can see the exhaust come out of the tailpipe, but we were able to look at what would the building sector use. And by building sector, we combine residential and commercial building operations, so that's heating, lighting, cooling, HVAC, plug load, all of those things, together with the embodied carbon and energy associated with building the buildings, making the materials, constructing the buildings. And there we came up with a building sector. And Ed always likes to say he fell off his chair when he saw this number. 48%, close to 50% of all U.S. energy consumption is attributed to the building sector. Transportation and industry are about a quarter each. So this really changes the way we look at the picture again. And what does that mean when we break it off? Many of you have probably seen statistics from the Energy Information Administration, the DOE, the EPA, USGBC, and they all usually talk about building operations. They'll say about 43% of U.S. energy consumption is the building sector, and they're talking about building operations. Heating, hot water, cooling, ventilation, lighting, plug loads. When the remainder of that other 5.5% is what it takes to make the building materials and to construct the buildings. And again, because we're tied as a fossil fuel-driven energy economy, CO2 emissions are still very closely tied to that number, 46%, almost 50%, half of the CO2 emissions are attributed to the building sector. And then here's the big one. We want again to talk about coal. Well, 75%, 3/4 of our electricity consumption goes just to power building operations. So this is not to construct the buildings, this is just every day we turn on the lights, we turn on our energy systems in our buildings. They're consuming 75% of the energy. Transportation, less than 1%. And if you look at the projections, that's not going to go up even with electrification of vehicles, much more. It's really going to be the predominant user is the building sector in terms of electricity consumption. So again, we're tying it back to coal. How do we tie it back to coal? Well, the electricity sector produces 80% of its CO2 emissions through coal. It's about 40% now of all the electricity consumption is powered through coal, but it's 80%, double that, comes from its CO2 emissions. That's because coal, as many of you know, has the most CO2 emissions per unit of energy in terms of its output. So there we're starting to tie now the building sector back into that equation. And then that's not to mention all of the mini power plants that we do when we create buildings. You know, this is a great example of a building that's probably not using any fossil fuels on site. And I'm not necessarily advocating for that as a long-term solution, but we have to think about our design choices when we're putting in systems into a building. Is it going to use a fossil fuel-driven system? Is there a replacement system for that if we want to move away from fossil fuels? Every building acts as a mini power plant. So how do we affect the building sector? It's so large. If we were to put it all in a box, it would be about 275, closer now probably to 300 billion square feet of building space, residential and commercial, in the U.S. This isn't a global statistic. This is a U.S. statistic. We lump it all into a box. How do we even begin to change the landscape? There's so many buildings out there. Well, just in day-to-day practice, every year we demolish about 1.75 billion square feet. Just level it and start over. So that means that in the next 12 years, we're going to actually demolish a good portion of what's left of that block. Every year we renovate about 5 billion square feet of that building stock. These are major renovations, major mechanical system upgrades, lighting system upgrades, complete gutting and overhaul of the facades. We just basically keep the core and shell and put it back together. 5 billion square feet. This held true during the recession. We were still doing about 5 billion square feet. The new construction industry tanked, of course, but the renovation industry stayed fairly level. So that means that when we look at what's left in the next 12 years, that's how much will be renovated. And in good years, we were building 5 billion square feet of new construction. In the recession, it was about half that. We were about 2 to 3 billion square feet. Their projections are that we're still starting to kick back up to the 5 billion square feet a year. Things are starting to look up a little bit more. So we're going to build a lot of new buildings within that next 12-year time frame. So what we can see is this is a historic opportunity where there's about 3/4 of that built environment in 12 years will be new or renovated. Now we can start to change the way that those buildings consume energy. And in order to do that, we launched the 2030 Challenge, which is one of the main focuses for today. The 2030 Challenge was launched in 2006, and what it was, it's a set of performance goals for design and construction of new buildings and major renovations. And in 2006 when we launched, we said, if you're designing a new building, a school here at Thurston County, we want you to design to a 50% reduction in performance standard. In 2010, that jumped up to a 60% reduction, and every 5 years it increases 10%. So by the year 2030, we have carbon neutral buildings. And what we mean by carbon neutral is that it uses no fossil fuel, greenhouse gas emitting energy to operate. Not that it doesn't use energy, it's just highly efficient, typically 80% more than that baseline building. And the energy that it does use comes from on-site renewable energy, like the photovoltaic panels we see outside, or from offsets or renewable energies off-site. And how do we say we get there? Well, number one, we say is design strategies. I'm sure if we look at this building and when we go through the tour, there's a lot of passive strategies, design strategies that came from the mind of the designer before he put pen on paper that really affect the energy consumption of the building. How it's sited, where the windows are placed, all of that has a really large impact on energy consumption. And in fact, they were getting 50, 80% reductions from the baselines back in the 80s. All of that can happen through design. It's just knowledge, no cost. Then you move into, if you can't make it to those 60% reduction target now, you get the most efficient technologies. You start looking at efficient HVAC systems, lighting systems, control systems. You bring in some on-site renewables onto the building. And if you still can't make it, then we're allowing you to buy some offsets or renewable energies off-site, but we don't want you to buy your way out of this problem. So we limit the amount of offsets that we allow for people to buy to 20% of that reduction standard. So that means by the year 2030, that building is at least 80% more efficient than a typical building of its type, and it has the rest from renewable energy either on or off-site. So who's adopted the 2030 challenge since we launched in 2006? Pretty much every major building sector organization and plenty of governments and city, states, and federal government have adopted the challenge. So the AIA was one of the first adopters in January of 2006 for all of their 80,000 plus members. And they put it into their position statement and now have launched an AIA 2030 commitment program for AIA firms to start reporting on the projects that they're designing. We have the U.S. Green Building Council as a strong supporter. If you're saying we support the 2030 challenge, and if you design a building to LEED standards, you're going to get to that 50% reduction in energy and carbon emissions. And we also had the U.S. Conference of Mayors, which was led by actually Mayor Nichols in Seattle at the time for Resolution 50 in 2006. And there was 4 other partners, in Mayor Daley in Chicago and Mayor Diaz in Miami. And what they said is that we want all buildings in all cities that are participating in the U.S. Conference of Mayors to meet the 2030 challenge. And some of them have done it in different ways, some through ordinances, some through building codes, others through incentive programs, but they're all trying to move towards the 2030 challenge for their built environment. We also have 73% of the top engineering and architecture firms that have adopted this. These are the real big global players. This is DLR Group, Perkins & Will, HOK, HKS, ZGF, all of the really big players that are moving. And not only are they moving to meet the 2030 challenge 60% reduction goal, many of them start their designs at carbon neutral or net zero. That's where their starting point is now. So the industry is already moving in this direction. We'll see that we're actually making quite a bit of progress. I mentioned that the federal government has adopted it. In 2007, in the Energy Independence and Security Act, there's a Section 433 that George Bush signed into law, which makes that all federal buildings, new construction projects, and major renovations have to meet the 2030 challenge target starting in 2010. The current existing one is a 55% reduction standard. So if you're working on federal projects or you're aware of federal projects, they'll have to meet the standard, and it increases just like the 2030 challenge does, so that by the year 2030, we're designing basically net zero carbon neutral buildings. There's been a couple of proposed legislations in the past to incorporate the 2030 challenge into a national mandatory building code. There was bills in the House of Representatives to tie the 2030 challenge reduction targets to a national model building code, as well as in the Senate. There's been 2 that have, these are bipartisan supported, by the way. That they passed committees, they just never got signed into law. And we have codes ready to start meeting some of these. The new IECC 2012 is roughly equivalent to a 50% reduction from the average. We have the new IGCC standard, which is about the same. So we're starting to increase the level of efficiency of our codes, and Title 24 in California is beyond some of these already, and Seattle Energy Code is beyond some of these. But we have codes available and standards that we can put in place into our municipalities in order to meet some of these targets already. It's just a matter of will. And in fact, the state of Washington signed a law, SB 5854, which I believe was about 4 years ago now, and that basically said that by the year 2031, they wanted the energy code to be 70% more efficient than the 2006 standard, which is essentially an 80% reduction from the average if we look at some correlation of how energy consumption is tied to the Washington Building Code. So essentially it's there. It got watered down. They actually originally, Bill had all the 2030 challenge steps up until then, but they only kept the long-term goal. But we still need to get that. We need to push our elected officials. We need to push the building codes sectors if we want to achieve these goals. It's got to be an incremental step. It's not like we're going to get to 2031 and all of a sudden have a really efficient code. It's going to happen in phases. So with all of that, how have we done so far? I mean, so many people have signed on to the 2030 challenge. People are starting to implement it in their practice. Are we seeing any results? Well, in 2005, this is the projection of from 2005 to 2030 of how much energy in building operations we're going to use. This comes from the Department of Energy, has a branch called the Energy Information Administration, and they produce these statistics every year. And this is where they said we were going to go in 2005. Well, that's really around the time that the green building movement started to kick in. We're starting to make some progress. We launched the 2030 challenge in 2006. And we see here in 2007, those numbers are going down in terms of the projection. In 2009, even further. 2011, even further. And here's the 2013 statistics that came out this year. We are making some significant progress. So we're actually leveling out energy consumption pretty much. We're bringing it down a little bit and it kicks back up a little. These are amazing results to see in just 6 years. And what are they saying also? They're saying, well, there's another scenario that if we adopt a best available demand technology, we can actually reduce energy consumption in the building sector significantly. What does that mean, building best available demand technology? That means that as you're renovating building, as the time of use comes up for certain equipment, that you're replacing it with the best technology off the shelf, not the cheapest. And even if you don't believe in climate change, if you don't care about the environment, if you don't care about greenhouse gas emissions, there's a huge economic activity here. This is the 2011s, but we're talking about $6 trillion of energy that we're saving here because we're applying some of these principles, because we're starting to reduce the consumption demands of the building sector. And then we look at the electricity generating capacity because, again, we're trying to tie it back to coal, and coal is being used in power plants to produce electricity. Here is the projections now in 2013. We basically leveled off any new generating capacity that's needed for at least the next 10 or so years. And these are really actually just the design strategies. This is residential at Energy Star level, which isn't hard to do. Plenty of even housing developers on track housing are building at net zero standards now at market rates in certain markets in Phoenix and Las Vegas, et cetera. And then for commercial, we just need to get 25% better shell by the year 2040, which we're already starting to do. This is easily done. And then if we add in the really high available demand technology, the one that we talked about before, we don't need new power plants. We can start phasing out all those dirty coal plants. This is a market-based moratorium on new generating capacity. It's just happening already. And a lot of people will say, well, those reductions that we're seeing, that's just due to the recession. I mean, we're not building as much, so we're not consuming as much energy. We haven't really done anything. Well, that's not true. What we can see here is that these are the projections, current projections for the next, till 2030. They're saying we're going to build 22% more buildings. Remember, we talked about 5 billion square feet a year. We're still going to increase our building stock, but our CO2 emissions are going to go down. I mean, that's due to design, it's due to construction practices, and it's due to renewable energy standards. But we're going to reduce our CO2 emissions while adding 22% more buildings to our environment. Pretty impressive. If we apply those best demand technologies, we're looking at an even greater reduction in CO2 emissions, almost 30% from the building sector. This is really exciting news, but we should redouble our efforts because there's more work to be done. This is what we would need to do if we were going to meet the 2030 challenge targets. Not only do we need to level it out, we need to bring it down significantly, but what's exciting to see is that here's where we are now. We're already beating those targets right now, but we have plenty of work to do if we're going to get down to that bottom section. Now, globally, picture's a little more grim. By the year 2030, 1.6 million more people billion people are going to be living in cities. Additional, we're going to start biggest mass migration we've seen on the planet of people moving from rural areas to city areas. I'm sure many of you already know that. And in order to house all those people, we're going to build or rebuild 900 billion square feet of buildings worldwide. That's a lot of building. And that's a lot of opportunity. Where are they saying we're going to get all the energy to power those buildings? Fossil fuel is how much we use now. This is current. If we look into the projections for the future, we're going to go up to 722 quads. This is where we're going to get the energy from. The only way out of this, we can't produce our way out of this situation globally. We need to conserve our way out of it. We need to stop the fact that we're going to be adding so many fossil fuels, allow the renewable energies to start replacing the fossil fuels. We can only do that through conservation. There's no way we're going to make renewable energy solve this problem. So in order to do that, we need a universal design language, and so I don't have time to go into this in great detail, but I encourage you all. This is probably one of the most exciting things that we've done. It just launched about 2 weeks ago. It's called the 2030 Palette. I encourage you to sign up for the beta version now. There's a website here. This is basically a visual online encyclopedia of design strategies from the regional planning level, city design level, building level, all the way down to components of a building. And this gives you rules of thumb and design strategies. So it gives you real knowledge based off all the best practice that's around the world, real-life photographs from all over the world, every different climate, every latitude, every type of design culture. And it's in a visual format for you to work with, because we understand that designers are visual people. You know, we're not going to necessarily just read it out of a textbook and apply it. We need to see how it was done in practice. Inform us before we put pen on paper, because so many of those initial design decisions affect energy consumption and resource consumption. As soon as we start making those wrong decisions, if we don't have that knowledge, we're fighting a never-ending battle to try to fix it. So let's get all that information into our heads now before we move forward. And especially as you're looking at Sustainable Thurston and the county planning, talks about infill development, habitat corridors, transit-oriented development, all of that has rules and strategies here. So I recommend looking at it. So that's my section on Architecture 2030 and the 2030 Challenge. And I'm going to jump into talking about the Seattle 2030 District, which I know many of you are very excited about. And I'm going to start by showing a short video. I think you'll get a little bit sense of the camaraderie and what's happening there by hearing it from the people that are involved. And then I'll go into detail about what we're talking about.
For events like the Vision2Action Symposia, your participation is vital for success. We hope to have the opportunity to hear your ideas and perspectives at future Vision2Action Symposiums. For more information on our past symposia topics and upcoming Vision2Action series, please visit our website at www.vision2action.us or call 360-789-9669.
Some of those folks are board members. A lot of major property owners that are participating. In fact, 40% of our board of directors and our membership is property owners, managers, and developers. So this is really their organization, supported by the public sector, with the city and the county being members, as well as energy service companies, architects, engineers, and other community-based organizations all being a part of that conversation. So really bringing everybody together.